So let's take a look at this one. A spherical balloon. When I say a spherical balloon, what shape am I talking about? Yeah, like a ball. Okay. Is being inflated, and the radius of the balloon is increasing at a rate of 2 centimeters per second. Part A. Express the radius of the balloon as a function of the time. So I am asking you to write a function. RT, radius in terms of time. So T is the variable I'm using. Sorry, I feel like I'm going to sneeze. Okay, can you tell me how I would find the radius at any given point in time? So it starts. That's radius of the. You're thinking more of in terms of the circle, but let's just think about it in this problem. It increases 2 centimeters every second. So at time 0, the radius is 0. After 1 second, the radius is 2. After 2 seconds, the radius is 4. After 3 seconds, the radius is 6. So how can I quickly find that? If I want to know at 12 seconds how big it is, times 2. So at any given time, the radius is 2 times the time. So that way I don't have to list it out. I can just find the radius at any given point in time. V. If V is the volume of the balloon as a function of the radius, find V composed with R and interpret it. So in general, anybody know volume of a sphere? This is one that does come up quite a bit this year. If you have your textbooks, to reference, your textbook does have some formulas in it that will be useful. Right there in the very back, the first page has nice reference formulas. So as far as what I would expect you to memorize, just the common things that you've been doing for years, like you should know how to find the area of a rectangle, those types of things. If you needed this on a test, I would give it to you, but for homework purposes, that back page does have a lot of these formulas. All right, now I'm asking you to find V composed with R. So I'm asking you to find V of R of T. So if I plug my radius, and 4/3 pi, my R is a 2t cubed. Now I could clean that up a little bit. 2 to the third is 8 t cubed, and 4/3 times 8 is 32 over 3 pi t cubed. Okay, that's my V composed with R. And then I asked you to interpret it. What does this formula tell me? It's the formula for V, and V is volume. And in here I have a T. What does T represent? Time. So you just found a formula so that if you know how long we've been inflating the balloon, you can quickly calculate the volume, how much air is in that balloon. Is that okay with everybody? Next one. So an airplane is flying at a speed of 350 miles per hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. Express the horizontal distance d in miles that the plane has flown as a function of time t. Let's draw a little picture here. So I've got an airplane flying, and you guys know that I am an amazing artist. Okay, so here's my airplane. And altitude, what's an altitude? Height. So altitude of 1 mile. So my height is a constant 1. At time 0, it passes over the radar station. So let's say here's our little radar station. Start off, and then the plane is flying this way. I want the horizontal distance the plane has flown as a function of time. So I want some kind of expression for this side. What would I call that? So this is my side D. How could you quickly find how far it's flown? So at time 0, it's flown 0. After 1 hour, how far has it flown?
350.
After 2 hours.
700.
After 3 hours. 1,050. So how can I quickly find it? 350 times t. All right. B. Express the distance s between the plane and the radar station. Where would that go in my picture? The plane's going to be out here. Yeah. I'm looking at this. I'm calling that s as a function of d. So I'm trying to find some formula for how I might find my s. I'm just looking at this picture. Bless you. This was a horizontal, this was a vertical, so this would be a right triangle. What formula can you use in a right triangle? A squared plus b squared equals c squared. So if you wanted to solve that for s, what would you do? You want to get s by itself? Square root. Get rid of a square, you add a square root. Normally we do plus and minus, but can you have a negative? No. So 1 squared is 1 plus d squared. So s is just the square root of 1 plus d squared. C. Use composition to find s as a function of t. So I want s in terms of t. So I don't want this d. What can I replace my d with?
350t.
On a test, we know we're not going to have a calculator, so if you left it like this, that's fine. You don't necessarily have to do 350 squared. If it were something small like 4 squared, would expect you to simplify that, but you could leave it like this. So this just allows us to find how far the plane is from the radar station at any given point in time.
So why doesn't the d squared cancel out?
Because there's more than one term. You can cancel under a radical if things are multiplied, not if they are added. Okay, so, all right, let's see if I can come up with a good explanation why. Okay, you know that if I said the square root of x plus 3 squared, that is just x plus 3, right? We agree with that. But if I said the square root of x squared plus 9, that is not x plus 3. Here's why. A square root means you should be able to take this thing times itself and get what was in the middle. originally. But if I FOIL this, I get x squared plus 6x plus 9, and it doesn't match up. So in order for the squares to cancel, it has to be one term, so you can't have things added and subtracted and do the square root of individual ones. Does that make sense? Okay. Other questions? So, an oil tanker crashed into an iceberg and has developed a leak. The radius of the spill is increasing 1.5 inches per second and has a constant depth of 1 inch. So this is something that would be applicable, right? If there is an oil leak in the ocean, we need to know how big is this going to get? What's going to be impacted? How big of an area are we looking at? So, part A. Express the radius of the spill as a function of time. So I need an equation for the radius where time is my variable. What would that be? 1.5t. Every second it increases an inch and a half. B, I want volume as a function of t. Okay. In general, we are talking about, so we have a circular oil spill, but it also has a depth to it, right? So we're looking at essentially like a cylinder here. Okay, volume is basically area times depth. So area of a circle is, you should know this one. What's the area of a circle? Pi r squared. And the height of this, I'll just call it h. So in our scenario, we want volume in terms of t. My radius is 1.5t squared. The h, how deep is this oil spill? 1 inch. .5 squared is 2.25 t squared times our 1, so we just get 2.25 pi t squared for the volume. So C, I want you to tell me what that means. What does that formula give me? It's a formula for V, and V is volume. So we're talking about how much oil has a variable of T, so at any given point in time. So it's saying the amount of oil spilled, or the volume of oil at a given time. All right. I want you guys to try the last one. Stone is dropped in a lake, creating a circular ripple that travels outward at a speed of 46 centimeters per second. So part A, even if you don't get anything else, you might have noticed that the part A is the same on every example we've done. I want the radius as a function of time. So how big is the radius at a given point in time? Just the speed times how long it's been traveling, so 46t. B, I want area as a function of t. We are talking about a circle. What's area of a circle? We used it in the last example, we talked about it. Pi r squared. So area as a function of time, I have to replace my r with a 46t squared. Now, again, on a test, you don't have a calculator. I don't care if you just leave that as 46t squared. You know, on homework, we do have a calculator. 46 squared is 2,116. So if you want to simplify that, you could. Either way is fine. C, interpret the composition. So this is a formula for area. So it gives the area of the ripple. And T is time, so at any given time. Just a way to quickly calculate that. Yes.
So if you like just do it like the 46 or whatever,
Mhm.
is the square still at the end, right?
Yes. Anything else? That's all I've got for you. So you've got the rest of the hour to